Viewers, welcome back to our online tutorial. Today we have a very nice looking indices. It's a jump question, but it looks very bogus. But we shall apply the laws of indices appropriately to simplify it, because the mandate of this project is to make mathematics and physics simpler again. Without further ado, we go and see how we can deal with this in a manner that will be understandable. Now, 6. If you express 6 as a product of its prime factor, that will be 2 times 3. Then if you express 9 in its lowest base, that will be 3 squared. If you express 4 in its lowest base, that will be 2 raised to the power 2. All divided by. Now, if I express 18 to the power of n in its lowest base, that will be 2 times 3 times 3 raised to the power of n. Then 2 to the power of n. And the next term there is 12. If I express 12 as a product of its prime factors, it will be 2 multiplied 2 multiplied 3 to the power of 2n. Now, at this level, I want to tell us about a peculiar law of indices. We call it the product power rule. This is to say that if you have a product of two numbers raised to a power, it means that each individual number is going to be raised to the same power. So the product power rule is different from the power rule. As you can see here, A multiplied by B is raised to the power of n. This becomes A to the power of n multiplied B to the power of n. With this law, we can write this expression as 2 to the power of 2n plus 1 multiply 3 to the power of 2n plus 1. Here we use the power rule. 2 times n is 2n. 3 to the power of 2n. Here we use the power rule. That will give us 2 to the power of 4n. Now, if you come to the denominator, 3 times 3, you and I know that's 3 squared. So I can write this as 2 to the power of n multiply 3 to the power of 2 or to the power of n, because of this 3 times 3 here. Then at the middle, you have 2 to the power of n. And if you come here, 2 times 2 is 2 raised to the power of 2. So I can also write this using the product power rule as 2 to the power of 2 or to the power of 2n multiply 3 to the power of 2n. What an interesting question. Very beautiful question. Now, as you can see, let's still work on the denominator using power rule. So I will only repeat everything on the numerator. So 2 raised to the power 2n plus 1 multiply 3 to the power of 2n plus 1 multiply 3 to the power of 2n multiply 2 to the power of 4n, all divided by 2 to the power of n multiply all over here. 2 times n is 2n. 3 to the power of 2n multiply 2 to the power of n multiply. Here we use the power rule. 2 times 2n is 4n. 2 to the power of 4n. Here we have 3 to the power of 2n. If this were to be a theory question, you should have garnered up to 2 marks. Now, if you see this expression, 2 to the power of 2n plus 1, 3 to the power of 2n plus 1, 3 to the power of 2n, 2 to the power of 4n. So we can collect like terms on the basis. if I write collect like terms, if I write collect like terms, I am not wrong. It therefore means that anything that has the base of 2 should be together. Anything that has the base of 3 should be together. So we will now come to the very next step. So I will write 2 to the power of 2n plus 1 and bring to the power of 4n close to it. So you can see this. This is like terms. I will bring 3 to the power of 2n plus 1 multiplied by 3 to the power of 2n, or divided by, if I come to the denominator, the same thing. 2 to the power of n, 2 to the power of n, and 2 to the power of 4n can be written together. I'll write 2 to the power of n times 2 to the power of n times 2 to the power of 4n, then the base 3 to the power of 2n times 3 to the power of 2n. So at this level, we are doing very well, extremely very well, because of the slow and steadiness. Now, 2 to the power of 2n plus 1 and 2 to the power of 4n plus 1. We can use product rule. Here, let me write it out in English. Using a product rule or multiplication law of indices. And the multiplication, using the product rule or the multiplication. Okay. There's a mistake somewhere here. Okay, power of n here is 2. Now, if we use the product rule of indices, it therefore means that the product rule will be applicable to this and this, this and this. And what does the product rule say? Say if two base numbers have different powers, all you need to do is to retain the base and add the power for exponents. So that's the law we are going to apply at this level. And when we do that, we are home and dry. If I use the product rule for this pair, it becomes 2 to the power of 2n plus 1 plus 4n. If I use the product rule for these two guys here, because I'm adding the bases, that becomes 3 to the power of 2n plus 1 plus 2n, all divided by, here, regardless of the fact that there are 3, the product rule actually says that if 2 or more numbers of the same base, it is not necessarily 2. It could be 3, 4, having different exponents, retain the base, and add the exponents. If we do same here, what we are going to have is 2 to the power of n plus 4n. We use that same rule here, the same thing happens. This becomes 3 to the power of 2n plus 2n. What a very interesting question. Now, if we do simple addition here, 2n plus 4n is 6n. So we can rewrite this expression as 2 to the power of 6n plus 1 multiply 3 to the power of 4n plus 1, all divided by 2 to the power of 6n multiply 3 to the power of 4n. This question is fantabulous. So at this level, we will now use the division rule. Using the division or quotient rule of indices. What we are going to have before we use the quotient rule is to align these guys together. So 2 to the power of 6n plus 1 can divide this. So if I rewrite this last step as this, I am not wrong. 2 to the power of 6n plus 1 divided by 2 to the power of 6n multiply 3 to the power of 4n plus 1 divided by 3 to the power of 4n. And what does the division rule says? If two base numbers are raised to different powers, subtract the powers. So if you apply the law for both guys here, means we have done a nice job. So if I apply the division rule here, what we are going to have there is 2 to the power of 6n plus 1 minus 6n. Multiply, I will apply the same division rule for this base 3 guys. What we have there is 3 to the power of 4n plus 1 minus 4n. Again, we perform a simple arithmetic operation. 6n minus 6n is gone, 0. 4n minus 4n is gone. So what we are left with is 2 to the power of 1 multiply 3 to the power of 1. So, and we know that a number raised to a power of 1 is the same as that number. So at the end of the day, our final answer to this problem is 2 times 3, which is equal to 6. Thanks for watching this video. Please do well to share it to your friends so that this project can go beyond this level to a higher level. Thanks for watching and God bless you.